Welcome back, IGCSE students. In the previous video we looked at some examples of direct variation where we had linear direct variation, and so this was in the form of y is equal to kx, okay, and you know that this is going to give you a straight line graph that might go out like here or straight up like here, depending on the value of the constant. Now today we're going to begin by looking at non-linear direct variation. So I think you're doing questions 1, 3, 7 and 8 for this, so I'm going to start with doing question 2 just to give you a bit of a rough idea of what to do here. Okay, it says y varies as the square of x. Y varies as the square of x, and y equals 4.5 when x equals 3. So if you read this, y varies as the square, excuse my bad writing, of x. What this means is that you've got a y equals kx squared function. Okay, so it's not going to be linear, of course, because this is a quadratic. Now, the information that we've got is when y equals 4.5, x equals 3. So what we do is we're going to plug these details into our formula. So we're going to go 4.5, which is our y value here, is equal to k, which I need to work out, times 3 squared. And so our next line will be 4.5 is equal to 9k. And then to get k by itself, I divide both sides by 9, so I get 4.5 over 9. So k is equal to, well, you can see that is 1/2. So my equation is therefore y equals half x squared, or you could write it as x squared over 2. Alright, now part B is find the value of y. So we want to know y is equal to what when x is equal to 2. So what we do here is we plug in our values. Y, which I don't know, is equal to 1/2 bracket x squared. I don't actually need that bracket, so I could go y is equal to 1/2 times 2 squared. Now 2 squared is 4, half of 4 is 2, so y is equal to 2 in this situation. And in part C, we are this time given the value of y, and in this case it is 32, and we need to find x. So we just plug it into that formula again. 32 is equal to 1/2 x squared. To get the x squared by itself, obviously we need to get rid of that half, and to do that we multiply both sides by 2, and here we will get x is equal to plus or minus the square root of 64, so x should be equal to plus or minus 8. Okay, that's a quick talk about nonlinear variation there. And let's now talk about inverse variation. Inverse variation, or inverse proportion. So in inverse variation, as one thing goes up, as one variable rises, the other falls. rather than in direct variation, we'll have the x's and y's going up together. In inverse variation, we'll get something more akin to this. So here you've got high y values, low x values, and here you've got high x values, low y values. So that's an example of inverse variation. Now, I'm going to do a couple of examples here for you, but a general formula for inverse variation is y is equal to k over x, where this is our constant of proportionality, and then y next to your variables there. Okay, so let's have a look at number 2. I don't think you have to do number 2. Let me just check. No, you don't. So we know that y varies inversely as x, and y is equal to 10 when x is equal to 2.4. So we set up our equation. 10 is equal to k over 2.4. And the reason I know it's k over 2.4 is because the question says varies inversely. So look out for the word inverse or inversely, and that's when you're going to use this formula. Okay, so I'm just going to move this across to the other side. So if I times 10 by 2.4, I should get 24. So 24 is k, and therefore my equation is going to be y is equal to 24 over x. Now in part B, I have to find the value of y. So y is equal to question mark when x is equal to 4. So all we need to do is chuck in our equation. Y is equal to 24, and then our x value is 4. So y is equal to 6. For part C, this time we know that y is equal to 2.5, and we want to find what x is equal to. So we go 2.5 is equal to 24 over x. We can rearrange this, so x is equal to 24 divided by 2.5, and when we plug that in, we're going to get 9.6. Okay. Let me give you another example. Let me do number 6. So number 6 here we have a table. And let me just maybe... Okay, here's my table. That's not very good, is it really? Let's just bang there and bang there. Okay, and then through the middle here. So here we've got our x values and our y values, and we know that we've got 2.5, 4, 25, and 20. So how do we find the missing values here? Okay. So have a look at 25 and 4. So you can find your constant of proportionality. So we know that k is 100. And therefore, we now can find the others. So if I know the x value is 2.5, I can say that is 100 over 2.5. And so that looks to be, I think, 40. And then, what the heck is this? I think this is meant to be a 20 over here, right? And if I know that y is 20, I can say 20 is equal to k, well, which I know is 100, isn't it? 100 over x, and therefore x must be equal to 5. So you can use that formula to help you with some of these scenarios here. Well, I hope that's a little bit of a helpful introduction as you go about doing exercises 8.7 and 8.8. Feel free to flick me a message on the ThinkWave platform if you are stuck on any particular questions. Alright, go well.